Astronomers have captured a new image of the interstellar object 3I Atlas, and it turned out to be quite surprising. Instead of the usual signs of a comet, we see signs of chemistry that don't fit known models, along with a dusty cloud wrapping around its core like a tear. This is only the third interstellar visitor we've ever seen, yet it raises more questions than answers. Most importantly, scientists are not even sure they understand what they're looking at. So what did this new image of 3I Atlas reveal? Why does its composition and shape challenge our ideas about cosmic visitors? And how will ESA attempt to intercept this comet near Mars? Let's dig in. To make sense of it all, we first need to step back and ask, what exactly are these interstellar visitors? Throughout the history of astronomy, we've only recorded 3 objects arriving from another star system. The first was the famous Oumuamua in 2017, a cigar-shaped traveler with no visible coma that defied expectations and sparked fierce debate about its nature. The second was 2I Borisov in 2019, whose appearance was more orthodox, a classic comet with dust and gas, essentially an ordinary comet that just happened to wander in from another star. And now we have 3I Atlas, discovered on July 1, 2025 by the Atlas telescope in Chile. And once again, the rule book is being rewritten. How did astronomers know that 3I Atlas was interstellar? Its trajectory gave it away. It practically screamed outsider. It's making a one-time visit, moving too fast for the sun's gravity to hold it. In fact, when first spotted, it was traveling at over 130,000 miles per hour on a steep, almost backward-tilted path through the inner solar system. A hyperbolic orbit like this means it will fly by once and never return. As UCLA astronomer David Jewett puts it, it's like glimpsing a rifle bullet for 1,000th of a second. You can't project that back with any accuracy to figure out where it started. What we do know is that the object is ancient. Calculations indicate that it came from the thick disk of the Milky Way, a distant old region of our galaxy, which makes it possibly older than our own 4.6 billion-year-old solar system. Early observations show 3I behaving like a comet, a blurry cloud of gas and dust that forms from evaporating ice known as a coma. But even in this instance, it broke the pattern. It became active much farther from the sun than expected. Data from NASA's TESS spacecraft later showed the comet was already brightening back in May of 2025, when it was about 6 astronomical units away beyond Jupiter's orbit. Normally, comets don't switch on until they're much closer and warmer. That was the first hint that its makeup might be very different from other comets we know of. Estimates of its size have also shifted. Based on brightness, scientists first thought its nucleus could be between 3.5 and 7 miles wide, which would make it the largest interstellar object seen so far. The rest of what we see is its glowing coma. Unlike the elongated Oumuamua, 3I doesn't show big changes in brightness, which suggests it's more or less spherical. The story of 3I Atlas could have ended as just a passing visitor, but its looks and chemistry made it the most puzzling interstellar comet yet. Hubble and Webb both detected things we've never seen before in similar celestial bodies. The first big surprise came when astronomers pointed the James Webb Space Telescope at 3I to study its chemistry. On August 6, 2025, Webb used its infrared spectrograph to examine the comet's coma. JWST found that the fuzzy atmosphere was dominated by carbon dioxide. In fact, there was about 8 times more CO2 than water vapor. For reference, in most comets in our solar system, water is the main volatile that sublimates, while carbon dioxide usually plays a minor role. But here, the CO2 to H2O ratio is 8-to-1, making it one of the highest ever recorded. The only similar case scientists could point to was a distant comet named C-2016-R2, but even that wasn't quite as extreme as 3I. This rare and peculiar chemistry strongly suggests that 3I formed in an environment very different from our solar nebula. But how could a comet hold so much carbon dioxide compared to the amount of water? Scientists have a few hypotheses. One is that 3I formed near the CO2 ice line of its original star system, a zone far from the star where carbon dioxide could freeze. Another theory is that its ice was altered by radiation or stellar winds in its home system, changing its chemistry. Another possibility is that 3I has a thick insulating crust on its surface that traps much of its water ice inside. As the comet nears the Sun, only the more volatile ices like the CO2 and carbon monoxide can escape through cracks, while the water remains frozen until the comet gets much hotter. Theories aside, astronomers are watching closely because by late October 2025, 3I Atlas will reach its closest point to the Sun, a little beyond Earth's orbit, and it may reveal its true composition. Interestingly, by measuring the isotope ratios in the coma gases of 3I, researchers can get clues about its birthplace. In this case, the ratio of carbon-12 to carbon-13 in the CO2 is very similar to what we see in Earth's environment. That suggests that the material in 3I formed in a star system with a chemistry not all that different from the composition of our Sun. Paradoxically, it's both exotic in its high CO2 levels and familiar in its isotopic fingerprint. So did 3I form in the cold outskirts of a far-off system with a different balance of ice types? Or did it drift through the dark for eons with its carbon dioxide frozen solid, only to be warmed now by the rays of our star? The only way to answer that lies in the new image taken by Hubble, which we turn to next. While JWST was studying the chemistry of 3I Atlas, the Hubble Space Telescope focused on its appearance. Hubble captured a high-resolution image on July 21, 2025, when the comet was about 277 million miles from Earth. The resulting photograph is striking. Instead of a symmetrical halo, 3I is wrapped in a teardrop-shaped cocoon of dust around its core. It looks like a hazy, elongated glow with a bright head, as if the comet is spreading a broad fan of material to one side. Hubble confirmed that the dust is unevenly distributed. There's a wide plume of dust pointing toward the Sun and a much weaker tail stretching in the opposite direction. This is the opposite of the classic textbook picture of a comet. Normally, a comet's tail points away from the Sun due to solar radiation and the solar wind driving dust and gas outward. In fact, 3I does have a faint tail being driven away from the Sun. You can see some scattered material drifting outward in the images. But the dominant feature is the dust cloud facing the Sun. Astronomer David Jewett, who led the analysis of the telescope's data, noted that the object is clearly active and was already releasing dust heavily even when it was almost 4 times farther from the Sun than Earth. So, why does the comet appear to glow not only from behind but also from the front? The likely explanation is geometry and timing. 3I is racing toward the Sun at a steep angle, and when we observe it, we may be catching a large stream of dust blowing off the sunward side, similar to the beam of a car's headlights. Dust particles fly from the surface towards the Sun, then bend slightly under solar pressure, creating a broad curve of particles. Meanwhile, the classic comet tail is relatively weak. This unusual dust pattern may point to the possibility that 3I Atlas is approaching a star for the first time in a very long time. The image also helped refine the comet's size estimate. By analyzing the brightness distribution, Jewett's team set an upper limit for the nucleus at less than 3.5 miles across. It is likely smaller, possibly as narrow as a quarter-mile wide if most of the light is coming from the dust. For reference, the nucleus of 2I Borisov was believed to be about a mile across, and the nucleus of Oumuamua only 100 to 200 yards. A report from the Las Cambras Observatory also noted that all three interstellar objects appear very dark and reddish, reflecting only about 5% of sunlight. This suggests that their surfaces are made of complex material rich in organic substances. Considering how much the comet's appearance has already amazed astronomers, imagine what will happen when it's observed not only from Earth, but from another planet. We'll get that chance very soon, in October of this year. We should note that as 3I speeds through the inner solar system, it won't come especially close to Earth, which is a relief in terms of our safety, yet a bit of a disappointment for Earth skywatchers. Its closest approach to our planet will still be about 168 million miles away, far beyond Earth's orbit. But this time, we have something that plays to our advantage. The comet's path will lead it much closer to Mars. On October 3, 2025, give or take a day, the comet will pass only about 18 million miles from Mars, roughly 0.2 astronomical units. This fortunate geometry means that spacecraft orbiting another planet will be able to attempt to observe an interstellar visitor. The European Space Agency quickly recognized this opportunity. Colin Wilson, ESA's lead scientist for Mars orbiter missions, recently confirmed plans to observe 3I during its close pass by Mars. The ESA will employ two orbiters for this task, Mars Express and the ExoMars Trace Gas Orbiter. Express will use its high-resolution stereo camera, meanwhile TGO will use its color stereo camera and even its spectrometers. That means they will not only capture images, but also try to detect which gases are present. So what do scientists hope to gain from this flyby? Even though 30 million kilometers is still a significant distance, Mars offers the best vantage point. If the comet is bright enough, the cameras on the orbiters may see whether the coma has any asymmetry or structure and may even get a rough idea of the shape of the nucleus. The resolution is not high enough to show surface detail, but it may be acceptable for the task of providing color data to complement what Hubble and other telescopes get to see. If the gas emission is strong, the spectrometers could pick up molecular signatures such as spectral fingerprints of water, carbon dioxide, or carbon monoxide in the comet's tail. NASA's resources on Mars may also join this mission. The long-running MAVEN orbiter, which studies the Martian atmosphere, the Mars Reconnaissance Orbiter, and China's Tianwen-1 all carry cameras that could be repurposed to take images of 3I during its flyby. This could become a global initiative beyond Earth, a coordinated interplanetary observing campaign. Meanwhile, in the farther reaches of the solar system, other spacecraft may also be able to take a look. ESA's JUICE probe, currently on its way to Jupiter, plans to attempt observations in November 2025 if conditions allow. JUICE has some limitations because of thermal guidance, but its team still intends to use 4 of its instruments to gather as much data as possible about this comet. Even NASA's Lucy probe, traveling toward the Trojan asteroids, has been mentioned as a potential observer. Now think about what that means. If we ever want to send a spacecraft to chase down an interstellar object, being able to practice with the use of Mars orbiters in this way is priceless. We're learning how to quickly coordinate because interstellar visitors don't give much notice. 3I Atlas was only discovered a few months before its best observation window. The Mars orbiters are ready to observe, but even before the first images come in, some scientists have floated bolder ideas. Why do some see 3I Atlas as a natural object while others think it might be something artificial? Whenever an interstellar object makes the news, it seems to attract its share of mystery and speculation. In the case of Oumuamua, our first visitor of this kind, it lacks of a coma, and its odd acceleration led some, including Harvard professor Avi Loeb, to suggest it might be an alien probe, an idea that sparked fierce debate in the scientific community. Now, with 3i Atlas, we're witnessing unusual features once again, and Loeb, along with other scientists, has once more raised the possibilities of what if. He pointed to the strange glow ahead of the comet and suggested it might not be an ordinary comet at all, even revisiting the possibility of alien technology. Could its trajectory be fine-tuned? Could its unusual brightness be a sign that it is not a naturally occurring object? After all, who wouldn't be intrigued by the idea of an alien craft passing through our solar system? Let's take a critical look at that hypothesis. The claim that 3i lacks a tail and lights up from the front can largely be explained with what we already know. Hubble did see a tail, though very faint, and the bright dust plume facing the sun is a natural result of a one-sided gas release. The dominance of carbon dioxide puzzled scientists at first, but there are natural explanations, such as its birthplace or radiation exposure. No data so far, whether chemical, visual, or orbital, requires an artificial origin to explain it. Its orbit, while fine-tuned in the sense that it's hyperbolic and comes from a specific galactic direction, it fits with ejection from a distant star and a long drift through space. It shows no unexplained deviations that would suggest engines or anything non-gravitational. The fact is, the trajectory of 3i Atlas continues to follow the pull of gravity. Still, unconventional ideas have sparked some creative proposals. One more striking suggestion from Loeb and his colleagues was to use NASA's Juno spacecraft to try and intercept the interstellar object. Juno is currently orbiting Jupiter, and in mid-2025 they propose firing its engines to slingshot off Jupiter and aim for 3i Atlas as it leaves the solar system. According to their calculations, if Juno made the maneuver in August or September 2025 and used Jupiter's gravity in an O-berth maneuver, it could reach a trajectory that would pass the comet in late 2025 or early 2026. The catch is that this would require a velocity change, resulting in huge additional fuel expenditure, and Juno was never designed for an interstellar chase. It is an ambitious and risky idea, probably beyond the limits of the craft's remaining fuel and engineering capabilities, and NASA has shown no sign of seriously considering it. However, this illustrates how eager scientists are to have a closer look. Even a quick flyby, imaging the nucleus or directly sampling the coma, could answer many questions. Loeb argued that instead of ending Juno's mission by plunging it into Jupiter as planned, why not repurpose it in the name of a bold exploration? In the nearer future, missions like the Comet Interceptor should be ready for the next interstellar visitor. Led by ESA partnership with JAXA, the Comet Interceptor will launch to a parking spot in space and wait. If a new comet is discovered with a favorable trajectory, the spacecraft can be sent to intercept it, releasing small probes for close-up, multi-angle observations. All astronomers, whether cautious supporters of natural theories or fans of more exotic proposals, agree on one thing. We need more data on these interstellar objects. Before 2017, we had never seen one up close. By 2025, we have already observed 3. Each one is a piece of another star system that we can study here and now. They may carry clues about whether life can arise in other systems or reveal new astrophysical processes we've never seen before. And if one of them does turn out to be an alien ship or probe someday, would we not want to be able to recognize it? But one thing is certain, we are no longer limited to studying objects that orbit the sun. Whatever secrets 3i Atlas eventually reveals about its mysterious homeland, the next object may be even more astonishing. As we prepare to say farewell to this interstellar comet, we can't help but wonder, when will the next visitor from deep space arrive, and will we be ready to uncover its secrets and learn what it has to teach us about the universe, and perhaps even about ourselves?